Dear students, we are starting UV visible spectroscopy, and this is our first short lesson. Spectroscopy is actually an interaction of electromagnetic radiations with matter. Electromagnetic spectrum, as we know, consists of all these types of radiations which have been divided because of their energy differences. There are some fundamental properties associated with electromagnetic radiations, and these are actually the wavelength, lambda, which is a distance between two consecutive troughs or crests of a wave. And the units of wavelength are normally the units of length, like meter, nanometer, millimeters, centimeters, etc. So the units of length. Shorter wavelength will have the units like nanometer, etc. The longer wavelengths have units of like meters and even kilometers, like the radio waves. Frequency, denoted as nu, is actually number of waves passing through a point in 1 second. So for example, this is a point. So how many waves are passing through that very point in 1 second will be the frequency. And the units are cycle per second or hertz. So if we relate wavelength with frequency, we can say if the wavelength is shorter, there will be more number of waves passing through a point in 1 second, because all waves travel with the velocity of light, so it depends upon wavelength. If wavelength is shorter, there will be more number of waves passing through a point in 1 second. If the wavelength is longer, there will be less number of waves passing through a point in 1 second. So frequency is accordingly low or high. Third important parameter which is considered is wave number, that is nu bar, and wave number is actually inverse of wavelength. So the units are like centimeter and hertz. So these two parameters, they are important: wavelength, frequency, and wave number. And they are related to each other with the Planck's equation. E, that is energy, equals h, which is Planck's constant, into nu, which is frequency. So we can say the energy of these electromagnetic radiation is directly proportional to frequency. Higher the frequency, higher will be the energy. Then frequency, that is nu, equals c over lambda. C is velocity of light, it's a constant. So we can say that the frequency and wavelength are, that is an inverse relationship. Higher the wavelength, lower will be frequency, and vice versa. Then we have 1 over lambda is equal to nu bar. So h, c, and 1 over lambda is replaced by nu bar. Nu bar is the wave number, inverse of wavelength, 1 over lambda. So all these three parameters are interchangeably used in different spectroscopies. And as far as the electromagnetic spectrum is concerned, we have cosmic, gamma, X-rays, ultraviolet rays, visible, infrared, micro, and radio waves. And if we consider the parameter of wavelength, so wavelength is increasing in this way, that is. And if we consider the frequency is inverse, has inverse relationship with wavelength, so frequency is increasing this way. And if we consider energy, because energy and frequency are directly related, so energy is also increasing this way. So we can say frequency and energy are increasing this way. So ultraviolet, say for example, will have more energy as compared to visible radiations, and in turn visible radiation will have more energy as compared to infrared radiations. So depending upon these electromagnetic radiations properties and their energy, they can interact with matter, and the interaction of these electromagnetic radiations with matter is what referred to as spectroscopy. Now if we refer to the ultraviolet and visible section of the electromagnetic radiations, we have visible section which is next to the UV section. So both these radiation groups are able to interact with matter in such a way that they can have an energy to excite an electron from a lower energy level to a higher energy level. That is an excited state, high energy state. So this is interaction, that the ultraviolet and visible radiations are capable of doing electronic transitions in molecules, in atoms, and the matter. So this is the very basic concept of UV visible spectroscopy, that there will be electronic transitions in molecules and atoms. And by transition we mean that an electron can jump from either a higher state to the lower state. That will also be a transition, and either it can go from a lower to higher state by absorbing radiation belonging to ultraviolet or visible section. So this is the basic concept of electromagnetic spectrum and its interaction with matter.